After 10 years at United Nations analyzing the world's toughest problems, I kept seeing the same pattern, brilliant problem identification but medical solution. That is why I started the AI Autopsy. I am Isaac and I help AI graduates like you build startups that actually work. Today we are looking at a problem that perfectly illustrates this pattern. Farmers around the world are losing about 40% of their crops just gone to disease they cannot even see coming. And when you calculate what that means, we are talking about $220 billion every single year vanishing from the global economy. But here is what really got me thinking. What if I told you that with some basic AI skills, you could not only solve these massive problems, but actually build business that farmers would pay you for? Okay, let's break this down because the problem is much bigger than most people realize. First, let's talk about soybean diseases specifically. Soybean rust can wipe out 90% of a field in just 2 weeks. 90%. Root rot causes 30 up to 40 yield reductions consistently. And the bacterial blight that costs USA farmers alone over $1 billion every year. Now, the human impact in Brazil, 40% of soybean farmers report major outbreak every single year. In India, small farmers are losing their entire livelihoods, and in the USA, Midwest farmers are spending $200 every hectare on fungicide, with 60% of that being completely wasted. And the current solution is they are just not working. Manual inspection is only 65% accurate. Lab testing takes 5 up to 7 days for results, by which time it is too late. And in developing countries, there is only about one agronomist per 10,000 hectares. So here is what is really exciting. The solution is actually pretty straightforward with computer vision AI. Basically, you train an AI to recognize plant diseases the same way your phone recognizes faces. The results are incredible. 95% accuracy in identifying diseases. That compares to human accuracy of just 65%. And the timing. This is the game changer. An AI can detect problems 7 to 14 days before the human AI can see anything. That is enough time to actually prevent the spread rather than just react to it. The technology stack is accessible too. Mobile Net B2 gives you 92% accuracy with just a 4 megabyte model size. ResNet 50 gets you 96 accuracy if you need more precision. And TensorFlow Lite make mobile deployment really straightforward. A real-world example proves this works. The PlantX app have over 10 million downloads with 90% user accuracy. FarmSense AI reduced the pesticide use by 40%, and Cropland increased the yields by 30% across 2 million hectares. Now, if you are thinking this sounds great, but I am just a student, let me show you exactly what you need to learn. The technical requirements are actually quite focused. Python, obviously, TensorFlow or PyTorch for the frameworks, the understanding of CNN architectures like mobile net and ResNet, and the transfer learning technique which let you to build on existing models. For data, there are amazing free resources. The Plant Village dataset has over 54,000 labeled images. AI Crowd Plant Pathology offers 18,000 high-resolution images. And Kaggle has multiple agriculture datasets ready to use. The tools are all free to start. Google Colab gives you free GPU access. Amazon Web Services and Azure offers 300 up to 500 in free credits dollars for startups. And there are open source agriculture AI models on GitHub you can build up on. The timeline. You could build a basic prototype in 2 up to 3 weeks if you are experienced developer. A production ready model might take 2 up to 3 months, and a mobile app adds another 1 up to 2 months for development. Okay, so here is what you are probably wondering: how do you actually make money from this? The market size is massive. We are talking about 500 million small farmers worldwide. The agri-tech market will reach $5 billion by 2026, growing at 20% per year. Revenue models are diverse and proven. Software as a subscription at 5 up to $20 per month per farmers. 5 per scan at 0.5 up to $2 per analysis. Enterprise contracts for 10,000 up to $50,000 per year. The government tenders up to $500,000 for original deployment. Look at existing examples. Plantex uses $10 monthly plans. Param Logos charges $150,000 per year. Tranis commands 15 up to $20 per hectare for premium monitoring. The financial projections are exciting. Year 1, 1,000 farmers is equal to 120,000 revenue. Year 2, 10,000 farmers is equal to $1.2 million. Year 3, 100,000 farmers is equal to $12 million annually. Now here is the best part: you do not need to bootstrap this yourself. There are grants that will literally pay you to build this solution. Specific grant programs are available now. Yes, the USDR SBIR grant $50,000 up to $250,000. The Gates Foundation $1,000 up to $1 million. World Bank Agri-Tech $5,000 up to $500, and Google AI for social good $100 up to $250. Success rates are encouraging: 20 up to 40% for early stage grants, 30 up to 40 for university programs. This funding is there for the taking. So here is your 30-day action plan. Week 1, download plant village dataset and build your mobile viable product. Week 2, validate with 5 up to 10 real farmers. Week 3, apply for 2 up to 3 grants. Week 4, get your first paying customer. I have created a complete starter kit with everything you need: dataset, grants, template, technical guides, it all in description, completely free. Stop just learning theory, start building something that matters. The farmers need is your skills, the opportunity is massive, the funding is available. Thank you for watching this video.